These notes show us 3 different ways to graph the same equation. Different methods will be more efficient depending on what form an equation comes to us in. First, let's understand these different methods. The directions say to graph each of these equations by first putting them into slope-intercept form. Remember that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So in order to get this equation into slope-intercept form, the first thing I need to do is I need to solve this equation for y. So I start with the original equation, 3x minus 2y equals 6. And I'm trying to get the y by itself. First, I'm going to subtract the 3x term from both sides. 3x minus 3x is no more. There's nothing there. I still have this minus 2y. And then here, I can't combine the 6 and the 3. These are unlike terms. So I have 6 minus 3x. Next, to get the y by itself, I'm going to divide everything on the left by negative 2. And to keep my equation balanced, I have to divide everything on the right by negative 2. Here, the negative 2's cancel out, and I'm left with just y. 6 divided by negative 2, well, a positive divided by a negative is a negative. 6 divided by 2 is 3. The next term, a negative divided by a negative is a positive. 3 over 2, I can leave it in its fraction form, and I still have the x. So this is in slope-intercept form. The only difference is this one is in y equals b plus mx. Remember that addition is commutative. So whether I put the mx first plus b or the b first plus mx doesn't matter. So this is the first equation in slope-intercept form. So now I have 3 different ways that I can plot this. The first method is simply by making an xy table and plotting some points. So I'm going to make myself an xy table, and I'm going to plug in some different numbers for x. I notice here that I'm going to be multiplying x by a fraction that has a 2 in the denominator. So if I choose multiples of 2 for x, that's going to make my life easier. So I'm going to try 0, 2, and 4 there. When I plug in a 0 for x, what does my equation look like? Y equals negative 3 plus 3/2 times 0. 3/2 times 0 is 0, plus negative 3 is negative 3. Next, when I plug in a 2 for x, I have negative 3 plus 3 over 2 times 2. 3/2 times 2, the 2's cancel out. And I have negative 3 plus positive 3. That adds up to 0. Now, here I have y equals negative 3 plus 3/2 times 4. In this case, this stuff on the right simplifies to 3 times 2 is 6, plus negative 3 is 3. So I get those 3 points there, and I can plot those 3 points and connect them together to make a line. Now I've got some graph paper. I'm going to go ahead and plot these 3 points. 0, comma, negative 3, 0, and then go down 1, 2, 3 is this point here. 2, comma, 0, I go over 2 and then up and down, none. And 4, comma, 3, I go over 1, 2, 3, 4, and up 1, 2, 3. And so I can connect these points to get the graph of the equation. Now remember, even though I took this equation and I rewrote it in slope-intercept form, when I rewrite the equation in a different form, it doesn't change which xy pairs work in that equation. So this line is still the line that goes with the equation 3x minus 2y equals 6. It's also the line that goes with the equation y equals negative 3 plus 3/2 x. These are 2 different equations that have the same line that goes with them. They have the same xy pairs that make them true. So one way that we can graph a line is by plotting some points that are solutions to that equation. The next might actually be a little bit more efficient. That is, a little bit quicker to get us to the right answer, and that's the slope and y-intercept method. Again, we have our equation, y equals negative 3 plus 3 halves x. It's helpful to remember which of these two numbers is the slope and which is the y-intercept. The slope, the m, is the coefficient, that's the number in front of the x, that's 3 halves. And remember that slope is rise over run. It's also helpful to remember that the y-intercept is the constant. It's the number that stands by itself. So in this case, it's negative 3. The y-intercept means that the point 0, negative 3 is a point on our line. I can use this information. All I had to do was look at the equation, and I can graph this equation without doing any more work. Notice up here I had to deal with multiplying fractions and adding negatives. I can actually graph this line without having to do any more work. So if I make myself an xy axis like this, the first thing I'm going to do is plot the y-intercept, 0, negative 3. So I go left, right, none, that's 0, and then down 1, 2, 3. So there's my y-intercept. That's one point on the line. Now I'm going to use my slope, my rise and run, to walk my way to a second point. So the rise is 3, so I go up 1, 2, 3, and the run is 2. I go over 1, 2, and I put a dot where I land. That's the second point on the line. I can use the slope again to get to another point on the line. 1, 2, 3, up, 1, 2, over. There's another point, and I can connect those points. Notice that that gave me the same 3 points as I had up here, but it sure was a lot faster and a lot easier. When you have an equation that comes to you in slope-intercept form, using the slope and the y-intercept to plot that line is generally your most efficient method. The last method that I'm going to show you is the x and y intercepts. In this case, what I'm going to do is I'm going to write the original form of the equation again. 3x minus 2y equals 6. Why did I switch back to this original form of the equation? Well, here's what I notice. When x and y are on the same side of the equal sign, using the intercepts to graph the equation is often much easier. And here's why. Remember, when we graphed the x and y intercepts, it was like we made a little teeny tiny table of points. One of them had 0 for the x coordinate, one of them had 0 for the y coordinate. Let's find out when x is 0, what does y have to be? So I take this equation and I replace the x in it with a 0. 3 times 0 is 0, so all that's left on this side is negative 2y equals 6. When I replace this x with a 0, this term goes away, and I'm left with a simple one-step equation that I can do in my head. I divide both sides of this equation by negative 2, and I get y equals 6 over negative 2, which is negative 3. Now I'm going to do the same here. I'm going to plug in a 0 for y. 2 times 0 is 0. 3x minus 0 is still 3x. And so I end up once again with a simple equation. This time it's 3x equals 6. This is a one-step equation that I can do in my head. I can divide both sides of this equation by 3, and I end up with x equals 6 over 3, or 2. This method is the easiest when x and y are on the same side of the equal sign, because when you plug in a 0 for x, one of the terms drops away, and when you plug in a 0 for y, the other term drops away. This method is actually a little bit harder to use if x and y are on opposite sides of the equal sign. Let's graph this line and verify that finding the x and y intercepts gives us the same line as the other methods did. So once again, I'll make myself an xy axis, and I'm going to plot the y-intercept first at 0, negative 3. That's you. And then the y-intercept at 2, 0. And when I connect those points, I do in fact get the same line that I had gotten using the other methods. This is good to know because whichever method I use of graphing an equation shouldn't change what the line that goes with that equation looks like. Next, I'd like you to try this, only using the equation that's shown at the top of the right-hand column. Negative 2x equals 4y plus 8. First, solve that equation for y so that you get it into slope-intercept form. Then, graph the line by plotting points. Then, graph the line by starting with the y-intercept and using the slope to walk you to another point. And last, find the x and y intercepts.